Hi there, welcome back once again to Universe Intelligence. Now, look around you. What do you see? You might say a chair, a table, perhaps a window to the world outside. But what lies between these objects? What fills the seemingly empty space? For centuries, we believed it was truly nothing, just emptiness. But the quantum world, with its bizarre rules, tells a different story. In the realm of the very small, emptiness is an illusion. Imagine the emptiest space you can, a perfect vacuum devoid of all matter and energy. In our classical everyday world, the space would indeed be nothing, but delve deeper into the quantum realm and you'll find it's far from empty. This is where the familiar laws of physics break down, replaced by a mind-boggling dance of possibilities and probabilities. The quantum world, with its paradoxical nature, challenges our very understanding of reality. It whispers that nothingness, as we perceive it, might not truly exist. Instead, it proposes a reality teeming with activity, a constant ebb and flow of energy and particles, even in the seeming void. So buckle up and prepare to journey into the heart of quantum weirdness. We're about to discover that even nothing is something extraordinary. In our everyday lives, nothing is a simple concept. It's the absence of something, the blank canvas before a painting, the silence between notes of music. But in the quantum world, nothing takes on a whole new meaning. It's not simply the absence of matter or energy, but a state of potentiality, a breeding ground for fleeting particles and unpredictable fluctuations. Imagine a vast dark ocean. On the surface, it appears calm and empty. Yet, beneath the surface, currents swirl and unseen creatures dart through the depths. This is akin to the quantum vacuum. It's not truly empty, but filled with a roiling sea of quantum activity, hidden from our everyday perception. This difference in perspective highlights the fundamental distinction between classical and quantum physics. While classical physics describes the world we experience with its predictable cause and effect, quantum physics governs the microscopic realm, where uncertainty reigns supreme. In this strange and wonderful domain, nothing is never truly nothing. It's a dynamic, ever-changing landscape where the very fabric of reality shimmers with uncertainty. At the heart of this quantum weirdness lies the concept of the quantum vacuum. Imagine the vacuum cleaner you use at home. It sucks up everything, leaving behind a void. Now, imagine a vacuum cleaner so powerful it sucks out even the tiniest particles, leaving absolutely nothing. You'd think you'd be left with, well, nothing. But in the quantum world, you'd be wrong. Because even when you remove all matter and energy, you're left with the quantum vacuum. And this vacuum, far from being empty, is actually a seething sea of potential energy. Imagine a pot of water about to boil. The surface appears still, but beneath, energy simmers, ready to erupt. This energy in the quantum vacuum isn't just sitting there doing nothing. It constantly fluctuates, creating and destroying pairs of virtual particles, like tiny sparks of existence that pop in and out of being. These fleeting particles, though ephemeral, have real effects, influencing the properties of atoms and even the expansion of the universe. The quantum vacuum, therefore, is anything but empty. It's a dynamic, energetic realm, a constant dance of creation and annihilation, a testament to the incredible strangeness of the quantum world. Let's delve into this quantum foam and meet its inhabitants' virtual particles. These aren't traditional particles like electrons and protons. They're fleeting fluctuations in the quantum fields that permeate space. Imagine a ghost flitting through a wall, a brief shimmer before vanishing. That's the life of a virtual particle. They exist for fractions of a second, borrowing energy and returning it. These particles arise in pairs like a tiny yin and yang. They annihilate each other, returning energy to the vacuum. They even play a role in the evaporation of black holes. In the quantum vacuum, there's a constant dance of creation and annihilation. Heisenberg's uncertainty principle, embracing the unknown. This dance of virtual particles is grounded in one of the most fundamental principles of quantum mechanics. This principle tells us there are fundamental limits to what we can know about the quantum world. Imagine trying to pinpoint the exact location and speed of a buzzing fly. Observing it, perhaps by shining a light, will disturb its motion. The more precisely you measure its location, the less you know about its speed. In the quantum world, this uncertainty is inherent. It's a fundamental property of nature itself. We can never know both the position and momentum of a particle with perfect accuracy. This uncertainty allows virtual particles to exist. They can borrow energy from the vacuum to briefly flicker into existence. Heisenberg's uncertainty principle governs the fabric of reality, allowing for the fleeting existence of virtual particles. Section 6. Observing the unobservable. Evidence from the quantum realm. The idea of a seething vacuum, teeming with virtual particles, might seem like theoretical speculation. But the beauty of science is that it's not just about abstract ideas. It's about testing those ideas against the real world, searching for evidence to support or refute our theories. And indeed, we have found evidence for the existence of virtual particles and the dynamism of the quantum vacuum. One striking example is the Casimir effect. Imagine two perfectly smooth metal plates placed very close together in a vacuum. You'd think there would be no force between them, right? But surprisingly, there is a force that pushes the plates together. This force arises because the virtual particles in the vacuum can't exist between the plates, as the plates restrict their wavelengths. This creates a pressure difference, with more virtual particles pushing the plates together from the outside than from within. This effect, though tiny, has been experimentally verified, providing tangible evidence for the reality of virtual particles and the dynamic nature of the quantum vacuum. It's a beautiful example of how even the seemingly emptiest regions of space are teeming with quantum activity. Section 7. A universe from nothing, the Big Bang and beyond. The concept of the quantum vacuum and its inherent energy fluctuations has profound implications for our understanding of the universe itself. In fact, it might hold the key to understanding the ultimate mystery, the origin of the universe. The prevailing theory for the origin of the universe is the Big Bang. But what caused the Big Bang? Where did all the matter and energy in the universe come from? The quantum vacuum, with its inherent energy fluctuations, might provide an answer. Some physicists believe that our universe could have originated from a quantum fluctuation in the vacuum, a tiny bubble of space-time that suddenly inflated into the vast cosmos we observe today. In this scenario, our entire universe, with all its stars and galaxies and life, could have emerged from a state of seemingly nothing. This idea, while still speculative, is incredibly profound. It suggests that the universe we live in, with all its complexity and wonder, might ultimately owe its existence to the bizarre and beautiful laws of quantum mechanics. Section 8. The philosophical puzzle of something from nothing. The idea that something can arise from nothing has profound philosophical implications. It challenges our intuitive understanding of cause and effect, forcing us to confront the very nature of existence itself. If the universe did indeed arise from a quantum fluctuation in the vacuum, does that mean there was truly nothing before? Or was there always the potential for something to arise, encoded within the fabric of reality itself? These are questions that have puzzled philosophers and theologians for millennia, and quantum mechanics doesn't provide easy answers. Instead, it deepens the mystery, offering tantalizing glimpses into a reality that defies our everyday intuition. Perhaps the true lesson of the quantum vacuum is that our very notion of nothing is flawed. Perhaps true nothingness, a state of absolute non-existence, is impossible, even in the realm of thought. Perhaps existence, in some form or another, is all there has ever been and all there ever will be. Section 9. The Neverending Quest. Unraveling the mysteries of the quantum world. The quantum world, with its strange and counterintuitive rules, is a constant source of wonder and amazement. It challenges our preconceived notions about reality, forcing us to expand our minds and embrace the unknown. The idea that nothing can truly exist in the quantum world is just one example of the profound mysteries that quantum mechanics continues to reveal. As we delve deeper into the realm of the very small, we're constantly confronted with new puzzles and paradoxes, pushing the boundaries of our understanding. But this is the beauty of science. It's not about having all the answers, but about embracing the unknown, asking difficult questions, and constantly striving to expand our knowledge of the universe we inhabit. So the next time you look at an empty space, Remember that it's not truly empty. It's teeming with quantum activity, a constant dance of creation and annihilation, a testament to the incredible strangeness and wonder of the quantum world. And who knows what other mysteries this strange and beautiful realm holds, waiting to be unraveled by future generations of curious minds.